As I've always said, it's tempting to read from left to right. In this case, that would lead you in the wrong direction. So we're not going to just do the 5 minus 3 right off the bat. We want to read according to PEMDAS. So we're going to do the work in the parentheses first. Irene, what do you see as the work that we could be doing in the parentheses first? That is correct. And when I do those exponents, 2 cubed I get. And the other one?
25.
Perfect. That makes sense to everybody? Yeah. Irene started us off in a good place. Yeah. Good? Okay. Any suggestions on what we could do next?
3 times 8.
3 times 8, which is?
24.
24. Joe, what would I do after that?
You would subtract 25 from 24.
And so when I do the work in the parentheses, I end up with?
-1.
-1. So 5 minus 3, parentheses, -1 squared. Okay, anybody see another good step here?
-1 squared.
And when you square -1 inside the parentheses, you end up with? 1. So 5 minus 3 times 1, and 3 times 1 is 3, and 5 minus 3, we should end up with a 2. You guys feeling okay about that one? Any questions? Okay, awesome job. Number 2, we've seen this before. Square root of blank parentheses squared minus blank parentheses squared. That's what we do when we're trying to evaluate an algebraic expression. And then we drop in the appropriate numbers. So the 5 goes here and the 3 goes there. Again, I want to remind you that a square root like this is sort of like a big grouping symbol. It's sort of like a big set of parentheses. And so we're going to do the work inside there first before we actually do any square rooting of anything. And so we go 5 squared, which is 25, minus 3 squared, which is 9. We continue on with the work inside the radical, the square root there. Square root of 16 is? We should have gotten a 4. Any questions at all on that one? Okay. And then finally we get down to our fraction question. And this is also an order of operations as well, simply because we've got multiplication and addition going on here. And so should I do the multiplying of those two fractions first, or should I add first?
Multiply.
Got to multiply, right? According to PEMDAS, we multiply first. Chase, over there, 2/3 times 5/4. How do I actually multiply those two fractions together?
Just the top and bottom, so 6/20.
Yeah, multiply those two, and 6/20 is correct. Finally end up with 6/20 plus 9/20. I'm now adding these. This, Chase, what do I need to do here?
Well, since you already have a common denominator, you would just add them together.
And when I add them, what do I get?
15/20, then you have to simplify.
And it simplifies to? So if you got 3/4, I think we're in pretty good shape. Any questions on any three of those three? Remember, tomorrow quiz, it'll look kind of like that. So if you look at any of those questions, you're like, oh man, I hope it's not on the quiz tomorrow. It will be. So maybe it would be a good time to ask. We're good? Fantastic. Very good. Okay, so the intro video last night, if you'll excuse me here, Jade. Intro video last night was on simplifying algebraic expressions, things like the distributive property, adding like terms, parts of an algebraic expression. Pretty brief video, I think, but it was about that. So what I thought we would do here today is we would work on some of these here together. And so I think I would like to see how you guys do with these first 4. So if you take a look at your page, I just want you to do numbers 1, 2, 3, and 4. I just want to see how this goes, see how much you're remembering from the video or maybe past classes you have had. We're still kind of in the pre-algebra-ish realm here. We're starting to move a little more in towards algebra with this, but I do want to see how you're doing. So take a minute, please do numbers 1 through 4. We'll check your answers here in a little bit. Wondering if anybody feels like maybe they have this. 5 times 6x. Any ideas on what 5 times 6x would be? Go ahead, Whit.
30x.
30x is right. So when you are multiplying two factors like this, they do not have to be like terms. 5 times 6x, that basically just means you have 5 6x's. That ends up being 30x. So 30x is right. Nice job. Any questions on that one? Okay, then number 2. 3 plus 7x plus 12. Of course, this is a different question, right? It's addition instead of multiplication. Any ideas on this? Anybody have any suggestions for an answer on this? Go ahead, Jaden.
15 plus 7x.
15 plus 7x is right on the money. That's exactly right. Isn't it tempting to say 15 plus 7 is 22? Why can't I say that this adds up to be 22x? Why would that be wrong?
Because you have to multiply 7 by x first.
Well, yeah, it would need to be a 15x, right, to go with the 7x. And it is kind of an out-of-order operations situation there. So, yeah, those are unlike terms, right? 15 and 7x are not like terms. So what Jaden said originally is definitely correct. All right, number 3, simplify completely 4x plus 9x plus 11. Again, suggestions from you. You think maybe you have the answer on this one? Any ideas? Whit, going for the double play here? Number 3.
13x plus 11.
13x plus 11 is right on the money. It's very good. He added his 2 like terms. 4x's plus 9 more x's gives you 13 of them. So 13x. The 11 is not like the x's. So it's just 13x plus 11. You guys still hanging in? Okay. Number 4. 2x times 5x times 3. What do you think there, Ben?
30x squared.
30x squared is correct. Take a look at what you have. Do you have the exact same thing? Exactly the same thing. If you do, great. If not, maybe we have something to talk about. Anything you want to talk about? So did we just go 4 for 4 for all 20 of you?
No.
What's that?
No.
Do you have any questions?
Why is it squared?
Ah, great question. So, Callie, a couple different ways to think about this. If you look at the 2 and the 5 and the 3, we're multiplying, right? And so 2 times 5 is 10, 10 times 3 is 30. Are you okay with the 30 part?
Yeah.
Okay. So then x times x. So the definition, so you basically still have the x times the x right there. The definition of x times x is 30x squared, right? So squared means times itself, right? And so x times x could be rewritten as x squared.
Okay.
The same way, remember when we did these, we did like negative 3 quantity squared, and we said that was the same thing as negative 3 times negative 3.
Mm-hmm.
Same concept, we're just reversing it.
Okay.
Right, so if negative 3 in the parentheses squared means negative 3 times itself, well then x times itself would mean x squared.
Mm-hmm.
So it's just kind of a definition of what squared is. Is that okay?
Mm-hmm.
Cool. Yep, you bet. Anybody else? Question? Thank you for saying something, first of all.
Yeah.
Right? Anybody else? But as soon as I said everybody went 4 for 4, Callie's like, no, not me. Just be honest about it. It's okay. I guarantee everyone in this class at some point will miss at least 1 point this semester. Guaranteed. Guaranteed. This happens. We're humans. Okay, so we're good to move on? All right, if you haven't already looked at numbers 5 through 9, I think you'll find some more challenges in there. Please take a look at those. This is. I will definitely pause and do some instruction as needed here. But I'd like to start off with number 5. I'd love to hear from you what you think this could be. I'd like to get somebody new, like Ben's volunteered, Whit's gone twice, Irene went once, Jaden went. Noelle, what do you got?
I said negative 5x squared plus 4x plus 4. What?
And
right?
was that a happy what?
Yes.
So you guys agree. What about the rest of you? Do you think that that's right?
I had another answer. I got that originally, but then I changed my answer.
Okay, what do you think, Ava?
Well, because there's a 5x squared and a 4x, I also thought, like, since to get the 4x, we had added, like, the 5 and the negative 1, and then they both have x's, so that'd be x squared.
Okay, so what's your suggestion? You're basically saying,
So I got negative 1x squared plus 4.
gotcha.
I
Hey, listen up. Do you understand? I think I understand what you're saying. Do you guys understand? I think that Ava is asking, hey, is it okay to add those two up? Are those like terms? What do you think?
No.
They are not like terms. They are not.
No, I mean, I added a square to it because to get the 4.
But you can't just add a squared to it. If you could just add a squared and it would be okay, I would take my salary and be like, squared. It's okay, right? Ava said it was okay. And Valerie would be like, whoa, your salary just got gigantic. What's the...
As long as you give me part of it, I'm fine with
Okay,
that.
well, because it was your idea, yeah. Unfortunately, you can't do that. You can't just go through and square something just because we want it to fit. If it fits, it fits. If it doesn't, it doesn't.
Well, because there were two x's is why I thought they
Oh.
squared it.
Got it. Okay, so this goes, that now I understand what you're saying.
Yeah.
I thought maybe you just said, hey, I decided to make it a squared.
No.
So then my whole idea with the salary is out. Never mind. Okay, so plus 5x and negative x, those are like terms, and so they can be added. But if you remember from the video, when you add like terms, you leave the variable the same, and you add the coefficients, right? So you would take the 5, the positive 5, and the negative 1 that's there, and you'd say 5 plus negative 1 is 4, like you did, but then you leave the variable as is.
Okay,
So 4x. Yeah, no. Hey, that's why we're doing this, right? Because I feel like you have some sense of what you're doing. And a lot of the times you'll get it right, but there could be some mistakes. Ava, thank you for asking. Much appreciated. So the original answer where Callie celebrated is right. So nice job. And Noelle, thank you. Good job there. That is your final simplification for that one. Ava asked a good question. Are there others? It's really good. Brought up some good points. Okay, fair enough. Take a look then, please, at number 6. 4x parentheses x minus 9. Joe, what do you think?
I think it's 4x squared minus 36.
4x squared minus 36. What do the rest of you guys think?
No.
No. Well, okay, so those of you that say that you think it's wrong, is it close or is it like way off?
Super close.
Super close. I agree with that. It is off by a little bit. What's missing?
By half.
Off by half. What do you think, Colton? What's missing? Say again? Let's talk about that. There should be an x on the 36, right? So does anybody identify, can anybody identify what this is? It is a distributive property because you have 4x, whatever that is, times a parentheses, right? And the parentheses is two terms in there, x minus 9. This is a distributive property, like so. The characteristics of the distributive property are it is a multiplication, like the 4x times, and then the stuff in the parentheses has to be like two terms, right? 2 different terms, 3 different terms, whatever it is a distributive property. So this right here would be the correct answer. This is our first example of the distributive property that we've seen here in our class today. Any questions? This gets a little bit tricky. Number 7. What do you think, Josh?
X plus 3.
X plus 3 is right on the money. Now listen.
Now, how old is that?
Listen carefully. Please listen very carefully. I'm going to erase Josh's correct answer. His correct answer is there. I mean, it's correct. Isn't it tempting to look at number 7 and see this?
That's what I did.
Can you, hey, before you just shout out a no, can you understand why somebody might see it that way? It's wrong. It's not the distributive property, but I can see why somebody would be like, oh, I think that might be the distributive property. And somebody might just go through here and be like, well, I'm going to distribute the 5. 5 gets distributed here, and they end up with 5x minus 10 perhaps, right?
Yeah, that's what I got.
It's really tempting to do that. Here is why it's not the distributive property. The symbol right here between the 5 and the parentheses is a plus. For this to be the distributive property, that symbol would have to be a, also known as multiplication. Yeah. It'd either have to be blank, which indicates multiplication, or maybe a dot, which indicates multiplication. If it is plus, it's simple addition. It is not the distributive property because the distributive property is a multiplication process. So all I would do here, instead of trying to do a distributive property, I would say that the 5 and the minus 2 are like terms. 5 plus negative 2 is 3. The x is like neither of those. So you end up with x plus 3 or 3 plus x. It's the same thing. Make sense?
Yeah.
Do you also see why I put that one in there? It's easy just to think that everything's the distributive property when that's not always the case. All right, number 8. Is number 8 back to the distributive property?
Yes.
It is. It is, because what's the symbol between the 8 and the parentheses?
Multiplication.
Nothing, which means multiplication. Coy, what'd you get for number 8?
8x plus 40.
8x plus 40 is correct. The most challenging one for the day is probably number 9. Maybe it's number 7. I don't know. Number 9, pretty challenging. It's 11 minus parentheses x minus 3. So we have 11 and we're subtracting something, but we're not just subtracting the x, are we? And we're not just subtracting the negative 3. What are we doing? Not just the x, not just the negative 3, but It's 11 minus something, but it's 11 minus...
Negative 3.
It's not just 11 minus negative 3. That's part of it, but isn't it also 11 minus x? In other words, it's not 11 minus x, it's not 11 minus negative 3, it's both. You're subtracting both. And so what sometimes people will do is they will look at this and they'll say, you know what, I want to distribute this subtraction. I want to distribute this minus sign, and this is totally valid. You could look at that minus as a negative 1 and distribute it, and if you do that, you would end up with 11 minus x, or minus 1x if you want, plus 3, because it's minus a negative. So do you see how I distributed that subtraction, or distributed the minus sign across? Now I've got two like terms. This gives me 11 plus 3, which is 14. 14 minus x, because the negative x is not like the 14. So 14 minus x. It's one of the trickier ones. We will do more like those tomorrow. So here's what we're going to do. I want to give you guys a little more practice. Oops. Here in about 10 minutes or so, we're going to switch over to our concept quiz 2, and then after that, for those that are ready for their retry, that are going to do the retry, we'll do that at the end. Okay? So if you guys would flip over to the next page, and if you guys would, please try, just start off with number 1. I think number 1 is a really good one for you just to focus on for a moment. Just focus on number 1. Yep, on the practice. Yep, the multiple choice. On yeah, well, I'll get there in a second.
Wait, are there multiple? Yeah.
Yeah, so it's possible to pick more than one. Indicate which of the following is an example of the distributive property. So we're looking for distributive properties here and eliminating those that are not. All right, I'd like to hear from you guys. Number 1, you guys think A is an example of the distributive property?
No.
It is not. You are correct. How about B?
Yes.
Yes, it is. That is a distributive property. How about C?
Yes.
Yes, it is. What about D?
Yes.
Also, it's written in the order that we're not used to, but that is still a distributive property. How about E?
No.
It is not a distributive property. What about F?
Yes.
And G?
Yes.
Yeah. Oh, why did I circle E? Because I was just getting circle happy there. Sorry. So basically, the only ones that are not the distributive property would be A and E. We were all saying the right things, and I just kept on circling stuff.
Classic.
Oops. Okay, so let's take the next 2 to 3 minutes, and let's do as many of the next practice problems that we can. You might be able to complete them all, so that's great. If not, just make sure you're focusing on quality work. You might want to, if you're only going to be able to do a couple of them, you might want to focus on the ones that look challenging to you, right? Focus on the ones that you need to work on. We'll go over some answers to those here in a couple of minutes. And again, you're welcome to discuss with a friend, there's a table partner there, and see how you're both doing. Here.
Someone said something. Intercom.
Oh, they did?
Yeah.
What'd they say?
I don't know. Someone something to the front. Desk.
Well, I couldn't hear them because it was loud.
Yeah.
If it's really important, they're probably going to call back. So number 2 is 3/10 x. When you multiply those two fractions together. Number 3 would be negative 14x plus 18. Number 4 would be negative x plus 13. Or 13 minus x.
Oh, okay.
Same thing. Same thing exactly. Just like this one up here would be 18 minus 14x. Those are the same things. Number 5, couple steps here. 12x plus 7 minus 10x. When I add my like terms, I get 2x plus 7. Or 7 plus 2x, same thing. And then finally you get to number 6. This one had a lot going on. My like terms, have you guys ever seen this for like terms where you put a box around
That's what I did.
the like terms? This is pretty common. So those 3 terms are like terms. So when you add those up, you end up with 5x squared. And then if you want to switch to a different color or different shape, negative 3x and negative 4x, those are also like terms. Those will add up to be minus 7x. And then the only person that doesn't have someone to add together with is the 12. There's no like terms with the 12. So 5x squared minus 7x plus 12 would be the simplifying there. Ben?
For number 6, will we have to like write out like steps?
No, I don't think so. I think if you understand like terms and if you can add integers, it really should just take a single step.
Yeah. Okay.
Yeah,
That's what I did.
I'm okay with that.
Cool.
Alrighty then. Hey, remember how we do the tables for quizzes?
No. Yes.
All facing the front. Please get them arranged like that. Ready, set, go.